All right, welcome in. This video we're going to cover Unit 2, Lesson 1, this is square values. Forgot my book again, so I had to print this, so I'm not going to be able to give you page numbers. Excuse me. Apologize. I believe this starts on page 39, if I'm not mistaken. We did this in class today. So, benchmark. Given an equation in the form of x squared equals p and x cubed equals q, where p is a whole number and q is an integer, determine the real solutions. So, obviously, we're going to be dealing with squares and cubes. Learning target, you guys are going to be able to use multiple representations to explore square values. Give me just a second, clean up glasses. Okay, so flip over. Next page would have, and I did print this. I believe this is a better copy than the last video I did. So I apologize for that. Hopefully this goes a little better. All right, so the warm-up, 2.1.1. Now, this is more, this is not math related, so I'm just going to read it and let you guys answer. So, learning something new can sometimes be challenging, but challenges are part of what leads to success. Failure is not the opposite of success, it's a part of success. That's Ariana Huffington. So, number one, it says, what would you want your teacher to say when they see you taking a risk, trying hard, or pushing through mistakes to learn something new? And then number two says, describe how it feels when you learn or accomplish something that is really challenging. Okay, we'll flip to the next page. Excuse me. 2.1.2, exploration. This is area of squares. So these all say complete the following with your partner. Well, I'm your partner. And that's kind of what we do in class anyway. I am going to start pairing you guys up more in class to kind of do some of these and work through them as we get a little faster. So, four figures are shown on the grid where each grid line is 1 unit. So this is 1 unit, and so 1 square, you'll see. So, all right, so find the dimensions. So figure A, so the dimensions, this is 1, and this is 1. So the dimensions are 1, we'll just go by 1. And the area, so 1 times 1 is 1. You see that's 1 box. All right, so figure B. So this is 1, 2, 3, and 1, 2. So it's 2 by 3 or 3 by 2, either way. And 2 times 3 is 6. If we count 1, 2, 3, 4, 5, 6. All right, figure C. This is 1 by 2. 1 by 2. And 1 times 2 is 2. And you notice that's 2 blocks. So this is kind of getting you guys warmed up to area later on. All right, figure D. So this is 1, 2, 1, 2. So 2 by 2. It's 1, 2, 3, 4, right? 2 times 2 is 4. So 2 by 2, and the area is 4. All right, so all the figures above are rectangles. Explain using dimensions which shapes are also squares. So remember, a rectangle is long. The long sides are congruent or equal. The short sides are congruent or equal. A square, all 4 sides are equal. So your rectangles are your 2 by 3 and 1 by 2, but your squares, because it's 1 by 1, it's 1, 2 by 1, 2. So I messed that up, but 1 by 1 and 2 by 2. And those are squares because it's the same number multiplied by itself. Okay. Yeah, all right. So next page. All right, this says form another group with another pair of partners, so still just me. Compare the squares each group created. Okay, well, So we don't have groups here, but if you were going to do squares, so 1 by 1 is a square, 2 by 2, because it's 2 times 2, 3 times 3, 4 times 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So all sides are equal. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. And if you count, say this is 1, this is 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you count these 4, 8, 12, 16, and then 5, 10, 15, 20. I didn't go far enough up. I thought that was the problem. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this would be 25. Okay. Let's see. Okay. All right. Let me do this. There we go. Okay. Got a little reminder here to flip this page. I've been one-sided, but this is going to be two. All right. So 213, bringing it together, or bring it together, area of squares. So number one, the area of the square shown is 64 square units. So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Hopefully, some of you guys knew that 8 times 8 is 64. All right, so label the length and the width of the square on the grid. So I already counted it. It's 8 and 8. Length and the width can be multiplied to find the area of 64. Since the figure is a square, the area can also be found by using, so this is area equals side squared. Area equals side squared. And you're just squaring the sides because each side's the same. So length times width is 8 times 8, or side and side. So that's why you say side squared instead of length and width like you do with other shapes like a rectangle. All right, so complete the equations for the square shown. So our area here is side squared. Our side is 8, a length of 8. 8 squared, or 8 times 8 is 64, or area is 8 times 8. Just so, going using the calculator here, let's, we got some weird stuff going on here. This calculator. Hold on. Okay, what is stat in there? I'm not sure. But let's just see. 64 square root, you get 8. Or 8 squared, you get 64. So just in case you doubted me. All right, so number 2. Consider a square with an area of 100 units. How long is each side? So remember, the area is the side squared. So if our area is 100, so side squared equals 100. So you would just take the square root of 100. And hopefully you guys know, but in case you don't, so 100, the square root button. So square root, so our side is 10. But hopefully you remembered, when you look at 100, think 10 times 10. And there you go. So explain how you determined it. We took, so, this is math, not English, so I don't want a ton of words, but what you would write here is just, you just said the square root of 100, because area equals side squared. All right, so this is going to go to the next page. So it says consider a rectangle with an area of 8 square units. Use the grid, it's on the next page. Draw possible rectangles with an area of 8 square units. So let me flip it over. So, oops. So we're looking for 8, say, units square. So the only two ways you can get, because remember, a rectangle is the one side is longer than the other. So the only way you're going to, two ways you're going to get a rectangle is to go 1 by 1, 2, 3, 4, 5, 6, 7, 8. So 1 by 8, or 1 times 8. And then the other way would be, we're going to be touching over here. Actually, let me just use a crayon. So 1, 1, 2, 3, 4 by 1, 2. So 4 times 2 is also 8. So that is your two ways of showing the rectangle. Explain whether it's possible to have a square that has an area of 8 square units. So no, because if you take the square root of 8, it's 2.8284. You see, it's a long number. And so because the sides have to be equal, um, so in this case, I mean they couldn't be equal because that's an irrational number. So that's why. All right, next page. Yeah, that was number 3. So yeah, number 4. Excuse me. Sorry, my nose is not good this evening. Okay. So the numbers 1, 4, 16, 25, 64, and 100 are examples of perfect squares. The numbers either 3, 8, and 200 are non-examples of perfect squares. And so why is this? So 1 times 1 is 1. 2 times 2 is 4. 4 times 4 is 16. 5 times 5 is 25. 8 times 8 is 64. You can't have two numbers that are the same that'll equal exactly 3, exactly 8, or exactly 200. 100 is 10 squared. Might be tempted to say, oh, 20 squared is 200. No, 20 squared is 400 because that 2 turns into a 4. So that's why. So we skipped this because I mean, we, basically we're talking about everybody defining or redefining what a perfect square is. So a perfect square is a number. So a number is a number that is the product of any number multiplied by itself. So your examples. So 2 squared is 4. Just say 9 squared is 81. 11 squared is 121. Any of these, so it's 11 times 11. It's 9 times 9. It's 2 times 2. So hopefully we understand. So it's any whole number that we are square or multiplying by itself. That's the definition of squaring. Because a square, and that's why we're talking about it geometrically and algebraically. So, geometrically, I showed you a square is the same length on both sides, and then a square of a number is the same number multiplied by itself. So, next section 2.1.4. So, square values on the coordinate plane. So, we're going to use the equation y equals x squared to complete the following, and it says with your partner. Well, that's me again. So, we're going to do this table. All we're doing is, and yeah, I did this on the board. It probably would have made a little more sense if I'd have done that, but it's okay. So we have our x, and x is going to be the first coordinate. So we're going to have this parenthesis. I'm going to go ahead and draw it all the way down. So it was -3 because that's the x. So here's -2. This is the x. That's -1. I'm going to go ahead and put them all in. But just keep in mind, again, the input's the x, the output is going to be the y, and it shows it like that. So 0, 1's the x here, 2's the x here, 3's the x there. All right. So up here, y equals x squared. So negative 3 squared, or, and we can put it here. Negative 3 squared is 9. So your y here is 9. So y equals negative 2 squared. And it's in parentheses because if you didn't have the parentheses, you would square the 2, which is 4, and it'd still be negative 4. But that doesn't work. We need to square x, and x includes the negative. So x squared, or negative 2 squared, or negative 2 times negative 2 is 4. So your y over here is 4. So let's square negative 1. Negative 1 squared is positive 1. All right, so if 0 times anything is 0. So y is 0 and x is 0 here. All right, so y equals 1 squared. 1 squared is 1. So if y equals 2, positive 2 squared, y equals 4. Sorry, x is 2, but all right, y equals, that's x is 3 squared, so y is 3 times 3 is 9. There you go. All right, compare the table values for the equation y equals x squared by substituting the given x values for the corresponding y values. Discuss with your partner. So they're all square. They're all perfect squares because whether it's a negative or a positive, when you multiply, when you square it, it's going to be positive because two negatives make a positive and two positives make a positive. And so negative 3 or positive 3 times 3 or squared is 9. 2 or negative 2 squared is 4. So, and then we're going to flip the next page and it's going to ask us to plot these. So hopefully you wrote everything down. So if you did, so we go negative 3. So remember x is left and right and y is up and down, right? Oops. There we go. So negative 3, 1, negative 2, 1, negative 2, negative 3. Positive 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2. Positive 4, 1, 2, 3, 4. Negative 1, positive 1. And again, so positive is right or up. Negative is down or left. When we're talking here. So x is left to right and y is up and down. But positive is to the right and up, negative is to the left and down. So just in case we forgot. All right, next one, 0, 0. So right here on the axis, both axes, that's the middle of the page. Then we got positive 1, positive 1, positive 2, then 4, because it's, again, perfect squares, and then 3 goes with 9. See, 9 is dark line up here. So there's our shape. And I didn't do videos, I think, for the first couple of sections, or at least the first section, but we went over the drawings, and this is your exponential, and this is squared. So now let's look down here. All right, so this is the graph of y equals x squared, and it does not go below the x-axis. See, it stops at 0, 0. Complete the following statements. All right, so we're going to talk about why it doesn't go below 0, 0. Remember, we're talking about perfect squares. So all right, so a positive number multiplied by itself results in a positive number. I'm going to put this in crayon here. And I talked about this earlier, so hopefully you remember. Had to get creative with because the printing was terrible on this. All right, so a negative number multiplied by itself results in a positive number. Therefore, for any value of x multiplied by itself other than 0, 0 times anything is 0. The y value will sometimes or always, it'll always be positive. So all points of the graph for y equals x squared other than 0, 0 are above the x-axis. All right, so we got here at the bottom, it says 4 coordinate pairs are shown. The points are represented also on the graph. Actually, it's back on the next page. I knew there was some sort of cutoff there. Sorry. All right, so next page, and this is it. So yeah, there's like there's some sort of cooldown at the end. It's again more, it's a graph, and I'm confused, and I'm good, and that sort of thing. So yeah, that's definitely up to you guys to fill out. But last page here. So we got 4 coordinate pairs here. The points are represented also on the graph. It says, I mean, you can graph it, but it's not on that graph because those are perfect squares and this is not going to line up. But anyway, locate and plot. If you guys want some practice, we can work on that. But what I want to get to is this here. So choose one of the points and show how it satisfies the equation y equals x squared. So this is again, so y, y, y. So I'm just going to pick this one and this one. So your y equals 2 point, so y equals x squared, y equals x squared. We're going to plug these in. So 2.25 is going to equal 1.5 squared. So is this true? 1.5 squared is 2.25. So yes. And then over here, negative 5 halves and 25 fourths. So this is your, again, x and y, but negative 5 squared, or negative 5 times negative 5 is 25, right? And then 2 times 2 is 4. So both of these satisfy this because y equals x squared. All right, so that's it for this lesson. If you have any questions, please let me know. You can send me a Sorry. Send me a message on Parent Square, or send me an email or comment on the video. Until next time, have a good night.